All right, so this next section that we're going to talk about includes graphs of functions that are not linear. And in some ways, in some instances, not even a function. These equations, these graphs are not even a function. So, as the problem of the day, you already know this, and we talked about it today in class a little bit, and definitely yesterday. How do I know if a function or if an equation or if a graph is a function, is actually a function? So let's take a look at this one. This is the graph of x equals y squared. Is this a function? If you remember the definition of a function, you will very quickly realize that if I draw a vertical line through any part of the graph, it touches two different points, and so it is not a function. Not a function. Because a function is defined in a way that every input has a distinct, discrete output. So input, only one output. Only one output. In this case, when I input 2, x equals 2, I get positive 1.4 roughly and negative 1.4. So I get two results. I get two outputs for one input. And so this is not a function. Okay, so moving on, let's go through a couple of examples of functions. Let's figure out or situations and graphs. Let's figure out if they're functions or not, if they're linear or not. So here's one example. Emmanuel walks the North Trail at his local park. The graph shows his distance from the fountain at the center of the park as he walks along the trail. Use the graph to answer the question. So first let's look at the graph. The y-axis, this is the y-axis. The y-axis is distance from the fountain. And the x-axis is distance on the trail. So as he walks on the trail, his distance from the fountain changes. So he's getting farther away from farther away from the fountain or closer to the fountain, depending on, how far on the trail he is. So when I look at this, it looks to me like as Emmanuel walks on the trail, initially he's going to get closer to the fountain. So this part of the graph shows he's getting closer to the fountain. Then for a while, excuse me, he stays the same distance from the fountain. And then at some point, he starts getting farther away from the fountain. I hope that makes sense to you. That's what I see when I look at this. So let's look at the question. Choose a statement that best describes the situation. Excuse me. The second section of the graph is nonlinear because it has no slope. Okay, is that true? Well, what is the slope of the second section, this section, of the graph? The slope is 0. That is still a slope. It is still linear. It's still a line. So that section is still a line. So the first one is not correct. The second one, each of the three sections of the graph is linear. This is true. The first section has a negative slope and it's constant. It's a constant slope. Doesn't change. So that's linear. The second section we just talked about, it is linear. And then the third section is also constant slope, definitely linear. So we know that the second one is correct. Let's check the next two just to see. Let me erase this. The entire graph is linear because it has a constant slope. Okay, do you see the difference between the second statement and the third statement? The second statement says each of the sections is linear, and that's true. The third statement says the entire graph is linear. That is not true because the slope changes. It changes from a negative slope to a zero slope to a positive slope. So if you take the whole graph together, it is not linear. So the third statement is not true. Finally, I'm sorry about the coughing. Finally, the second section of the graph is when Emmanuel gets to the fountain and rests. Why is that false? Well, he's not resting. He does get close to the fountain, but he's not resting because he's progressing from this distance on the trail to that distance on the trail. So he's continuing to walk on the trail. All right. So hopefully that all made sense to you. Let's move on to the. Okay, so question B. Which statement about the first part of Emmanuel's walk is true? So this is the first part of Emmanuel's walk, right here. Which part is true? The slope is negative, so his distance to the fountain is decreasing at a constant rate. Well, that sounds pretty good. Distance to the fountain is decreasing, and it's a constant rate. That sounds actually pretty good. I'm going to go ahead and mark that. The second point says the slope is negative, so his distance to the fountain is increasing. Well, that is clearly not the case, right? The distance to the fountain is definitely decreasing, so that's not right. The slope is positive. No, the slope is not positive, so neither one of these are correct. So it's got to be that first option. Okay, so let's look at the next question. Which of the following is true about the second part of Emmanuel's walk? So let's take a look at the second part. That's the part where the slope is 0. So the first question says the slope is 0, which means this portion of the hike is on flat ground. That's not what it means. There's nothing on here about elevation of the ground. It's just distance from the fountain and distance on the trail. So that's definitely not true. So not this one. The slope is 0, which means he is staying the same distance from the fountain. Okay, let's take a look at that. So this is distance from the fountain, and from here to here, that distance from the fountain does not change. So that's actually true. That's true. Let's check the other two. The slope is 0, which means he has not moved during this portion of the hike. Well, that's not true. He moved from this distance on the trail. Hang on. This distance on the trail to that distance on the trail. So he definitely kept moving. And then the final one, so that's not true. The final one is the slope is 0, which means he has decreased his distance from the fountain. We know that's not true. He kept the fountain distance the same, so the answer is the second one. Okay, all right, so let's go to the final question in this section. Which statement about the third section of the walk is true? Let's take a look at the third section. That's this part right here, going up. The question is, the answers are the slope is negative. Well, the slope is not negative, so we can just scratch that out. Scratch both of those out because the slope is positive. The slope from left to right, from this point to that point, the graph increases. So the slope is going up. The slope is positive, so his distance to the fountain is decreasing at a constant rate. No, because the slope is positive, his distance from the fountain is increasing from here up to here. So that's increasing. So it has to be the last one. It's not this one. It has to be this one, which says the slope is positive, so his distance to the fountain is increasing, and that's correct. All right, let's look at the next one. South Trail, okay? This is the same idea, distance from the fountain, distance on the trail. So what do we notice immediately? Is this linear at all? Well, no, it's a curve. In fact, there's no portion on this graph where it's linear. It's curving all the time. So let's take a look at the questions. Emmanuel returns to the park the next day and walks the South Trail. Choose the statement that applies to the South Trail. The South Trail is a faster way to the fountain. I don't know if that's true. We don't know about time. There's nothing on this graph that tells us about time. It's just distance. The South Trail is a curved path. Well, we don't know that either. We just know that his distance from the fountain gets a little bit less and then starts to increase. We don't know if that's from a straight line or a curve. The graph is curved, but we don't know about the South Trail. The South Trail graph is linear. We've already said that. It's not a linear graph. So it has to be the South Trail graph is non-linear. All right, now let's look at this last question. Choose a statements, so more than one statement, that correctly describe the situation. Early on, Emmanuel's distance from the fountain increases quickly, but the distance slows. So early on, does the distance from the fountain increase? No, it decreases. This is a decrease. So that's not true. Early on, Emmanuel's distance from the fountain decreases at a constant rate. That's also not true. It's shallowing out. It's not decreasing at a constant rate. Let me erase that. Whoops. The next one. Near the end, his distance from the fountain increases at a greater and greater rate. And that is true. See how this line just goes up and up and up and up and up. So that one is true. It's increasing at a greater and greater rate. Near the end, his distance from the fountain increases at a constant rate. No. The South Trail graph is linear. We already know that's not true. The South Trail graph is nonlinear. All right, so hopefully this was some good insight and practice. No practice problems for you. I will see you in class tomorrow, and we'll go over this more detail.